Hello. So this is going to be some homework help for AM1, lesson 2, 3. The stuff we did today in class. Let's scoot on over to our magic tablet here in a second, and we will see if we can bring up. Yeah. All right. Here we go. Here we go. Okay, so we're going to try and do problems 1, 4, and 5. Whoops, I don't want that. I don't want that. Wait a minute. What did I do? How do I get out of this? Here we go. Back to this. Okay, so we had problems 1, 4, and 5. I think you should know how to do those. We went over those yesterday. We're going to go over problem 2, 3. And I'm going to start actually on problem number 3. And I think you should be able to maybe figure out number 2. I'll give you a little hint on number 2. So we're talking about this bacteria. And remember, bacteria don't grow. Bacteria don't grow in a linear fashion. When, if this is the size or the number of bacteria, the number of bacteria, and this is time, it doesn't grow linearly. Instead, it grows, I'm going to erase this, instead it grows what we call exponentially, and so it goes like this. It starts off kind of slow and it grows really fast, this number of bacteria in a bacterial colony. So, that's kind of a messy graph, but you basically get something like y equals 2 to the x, something like that. And that thing grows really fast. So watch what happens when we make this chart, right? So if we make this chart and we say, well, x is 1, then 2 to the 1 is 2. 2, we'll just write this down like this, 5, 6. 2 to the 2 is 4. 2 to the 3 is 8. 2 to the 4 is 16. 2 to the 5 is 32. 2 to the 6 is 64. And this is growing pretty fast, right? Now, when you get up to 2 to the, say, 2 to the 10th, you get 2 to the 10th turns out to be, I think it's 1,024. And if you get up to 20, you get 2 to the 20th, and you get, like, this is greater than 1,000,000. 2 to the 20th, I just happen to know that. 2 to the 20th is greater than 1,000,000. So this thing grows kind of slowly at first, but then it gets really big by the time you get to 20. So let's just look at this example. There's something else that grows linearly, and that's this bacteria in problem number 3. And so what they're saying is that we get 2 new ones every 30 minutes. So every 30 minutes, that's half an hour. So after 30 minutes, we have, it's going to double. So wait, so let's take this back a little bit. Let's take this back. Sorry. And let's actually answer the question. So at time 0, we have 100 of these. And you can read that in the problem. So that's the number of bacteria. And this is the time. At time 30 minutes, that's a half an hour. A half an hour, it has doubled. So every half hour, this thing doubles. So after a half hour, it's doubled. Then after an hour, it's doubled again. And after 1.5, it will have doubled. And after 2, and then it will have doubled again after 2.5. And then it will have doubled again after 3. So let's see here. So if we start with 100 and it doubles, every time it doubles, it doubles. So doubling 100 is 200. Now notice if this doubles again, it doubles again, in an hour, we have 400 because it's doubled from 200. It hasn't just got another 100. It doubles from this number. And then it's going to double from 400, and it's going to go to 800. See how this works? It's not linear. It's going to be growing kind of a little bit, and it kind of is going to start growing really fast. So you can keep going. You can keep doubling and doubling and doubling, and you can see where it is after 3 hours. And that's going to be your answer to number 3. You need to do that calculation. Now, here's another question. This is number 2. So on question number 2, we talk about dividing every 20 minutes. Dividing or doubling every 20 minutes for a day. For one day. Wow. Well, that doesn't sound like a lot, maybe, but let's think about what's going on. So in 1 hour, this thing doubles. It doubles 3 times. Because it doubles in 20 minutes, 40 minutes, and again at 60 minutes. So this thing doubles 3 times. So in 24 hours, it doubles. It doubles how many times? If it's 3 times every hour, and we do it for 24 hours, it's going to double 3 times 24 times, or 72 times. Now, if something doubles 72 times, it's not multiplied by 72. Watch what happens, just like we had before. If we have something that starts at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's watch what happens. So if it doubles, if it starts at 1, at time 1, and it doubles at 2, we go to 2. And if it doubles again, it goes to 4. And if it doubles again, we're at 8. So that's 1 hour. So this is 1 hour. Then this is going to be 2 hours, right? So 2 hours, so every 20 minutes, it's going to double. So if we double here, it's at 16 after 20 more minutes. And now 20 minutes from then, it's at 32. And then 20 more minutes, it's at 64. And now we're at 2 hours. Now after 3 hours, it's gone to doubles 128, doubles again 256, doubles again 512. And that's 3 hours. And let's just keep going and see. 4 hours, this thing is getting ginormous. 11, 12, 13. It goes to 1,024, 2,048, and then 4,096. So after just 4 hours, this thing's gone from 1 bacteria to 4,096. So the question is, if you kept doing this over and over, 72 total times, can this thing be bigger than 5,000 billion billion? Could it be this big? And so I encourage you to try it on your calculator, just on your calculator to hit, 1 times 2, 1 times 2 times 2 times 2 times 2, 72 times. And see what your calculator tells you. It's probably going to be a giant number, and I think that it actually could be pretty reasonable. But I want you to tell me what your calculator says after 72 times. So hopefully this was helpful. We're learning, again, remember, what we're learning about is exponential, that not everything grows in a linear fashion. Some functions work in a quadratic fashion, which is like x squared, and some grow at exponential fashion, which is 2 to the x. This is stuff you'll be using in science someday. Don't worry too much about the whole idea of how to calculate exponential growth. You shouldn't understand how to double something if the question calls for it, but don't worry about the expression 2 to the x and what that means. We're not going to be doing a lot of work with that, other than just know that that's another way that things can grow, and you will be using it in science. Okay, so good luck on your homework. And as always, the reason I put this video together is because someone asked. If you have any questions on homework or have any troubles with math, please send me a question on Schoology or email, and I will do my best to get it up on a video so that I can help you out. Have a good time doing the homework, and we'll see you tomorrow.